we're going to take a look at another theorem here, but we've kind of run out of clever names for the theorem, so we're just going to describe what it is, but it has to do with perpendicular lines. So what it says is that if two sides of two adjacent acute angles, two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Alright, so that's what we're trying to prove here. There's kind of a lot going on here, and we're going to take a look at why. But just because there's some things that we really haven't said before in a theorem, specifically referencing adjacent and acute angles. So let's go ahead and draw a diagram for this. So I have two sides of two adjacent acute angles are perpendicular. So essentially what I've got then are two angles like this, whose, let's see, two adjacent acute angles whose two sides are perpendicular. So I'm saying that I've got a right angle going on here. I will label some of these points. I will label this A, and this one will be B, and C, and D. And then just to make things easier, I'll label this 1 and 2 as my angles. And so I'm saying, so if two sides of two adjacent acute angles are perpendicular, which I have here, then the angles are complementary to each other. So there's a lot that we're just going to kind of assume from the diagram, but we're going to get this proof started here by first writing our givens and our proofs. So if I look at my givens, I say if two sides of two adjacent acute angles are perpendicular. So this is one of these proofs where the diagram kind of goes along with it. So this fact that they're adjacent and the fact that they're acute, I'm just going to be basically taking from the diagram. So my only real given that I'm going to be writing here is that the sides are perpendicular. So in this case, the sides would be ray AB is perpendicular to ray BD. Okay, which are just parts of lines that can be perpendicular to each other. And so then what I'm trying to prove would be that the two angles are complementary. In this case, I'm talking about angle 1 is complementary to angle 2. Okay, so let's go ahead and try and write this proof now. We'll start with our givens. AB is perpendicular to BD. And now we can put some thought into what we're going to be doing here. So I'm trying to say that angle 1 and angle 2 are complementary. So if I work my way backwards, what I'm essentially going to have to say that they do is they add up to be 90 degrees. Their measures add up to be 90 degrees. And so how do I know that? Well, the angle that they form here is a right angle. And the reason I know that is because AB and BD are perpendicular to each other. So I've kind of worked my way backward to my given. Knowing that this is a right angle that's formed will make these two angles complementary, essentially. So I just need to say those things in proof format. So the last thing I said there that I worked back to was that this is a right angle. So I'm going to say that angle ABD is right. And how do I know that? Well, the reason I know that is because these two rays are perpendicular to each other. So two lines are perpendicular if and only if they form a right angle. They form a right angle. Okay. I got run out of room. No. Okay. Where did that come from? That came from my only statement that I've made so far. So statement number 1. So what do I know about right angles? Well, if I want to talk about complementary angles here, the issue is I'm going to probably have to talk about measure. So I have to take this a step further and talk about the fact that the measure of angle ABD is equal to 90 degrees. And so this gets a little bit tedious whenever I talk about measures, but it's going to be worth it in the long run. And so why do I know this? Well, an angle is right if and only if its measure is 90 degrees. So now that I have a measure here, I want to end up connecting that the measure of angle 1, the measure of angle 2 has to be 90 degrees, but I have nothing connecting angle 1, angle 2 to this angle ABD. And so to connect it back, what I need to use is the angle addition postulate, which we haven't seen in a while. And so my reason for this, I can connect these all together here and say that the measure of angle ABD is equal to the measure of angle 1 plus the measure of angle 2, and this is my angle addition postulate. Angle addition postulate, which I'm just writing as the name because, as we've discussed before, it'd be a tedious thing to kind of write out. So angle addition postulate is one of the two postulates I'm just going to refer to by name. And so now that I have this all linked together, what I can talk about is, well, what does the measure of angle 1 plus the measure of angle 2 equal? Well, it has to equal 90 degrees because these two things are both equal to the measure of angle ABD. And so if I say that measure of angle 1 plus the measure of angle 2 is equal 90 degrees, that will be because of the transitive property. Whenever I have two things that are equal to the same thing, they must be equal to each other, which is the transitive property. So this links together statements 3 and 4 here. And so now I've done all this to say that the measure of angle 1 plus the measure of angle 2 is 90 degrees, which means that by definition they are complementary to each other. So angle 1 is complementary to angle 2. And the reason for that will just be the definition of complementary. Two angles are complementary if and only if their measures sum to 90 degrees. Measures sum to 90 degrees. All right, so here is one of the first proofs that we're doing that works with perpendicular lines here. And you can tell there's probably this pattern that's what we're going to see here. Whenever I have perpendicular lines, if I want to talk about angles in some way, I have to talk about a right angle, and then I might have to use a definition of a right angle to talk about 90 degrees, and then I can start linking some measures together. But what we've proved here is that if two sides of two adjacent angles are perpendicular, then those angles have to be complementary, which means that we can now use that in future proofs.